Okay, so we had given all the data sets, all the databases, and we had written the starting profile. We stopped in that one, right? Okay. Open the folder. Go back, go to your GAM course, input data. Okay. Open the management. Now we have given different crop types. This is the census of watershed, which Mr. Chaudhary was showing today. One of his case studies. The flower diagram. Yes, remember? Yes, no. It's the same watershed. Okay? So in that particular watershed, you have row crops of corn soil. He mentioned that if this year corn is growing, the consecutive year soybean will grow. Now the model does not know that. You will take a particular land use and it will have either corn or soybean as the water classes. We have to tell the model that this is the growing cycle with which it is going to work. And that is what we do in management practices. We usually get done through field survey. You go talk to the farmers or go talk to the local agriculture department. They will give you an idea what are the agricultural practices that are there. Right? So we have done a survey here in and around Warangal, Rashi, where we had discussed with the farmer like what they were growing, when they grow, approximate date, approximate time, and then based on that prepared the management practice. And that is what it is. So you have for a corn year, that means if it is starting from the corn, it starts on April 22nd. Again, you can do it based on the heat units, you can do it based on the date. Here you are following with the date, but April 22nd, first practice or first agricultural practice that they are going to do is nitrogen application. And what kind of nitrogen it has? It has anhydrous ammonia of 212 kg per hectare at that rate. It is all followed by phosphorus fertilizer P2O5 at the rate of 67 kg per hectare. And you also apply a pesticide on the same day, atrazine, that is 2.2 kg per hectare. This is on April 22nd. May 6th is when the tillage happens. They apply pesticide and fertilizer prior to tillage. Then they do tillage. There are different ways of doing tillage with different equipment. They use offset disc flow. Within the swag itself, there are numerous options. You can see them. And on the same day, planting happens. May 6th. Then in between, nothing happens. It's mostly rain-fed crop. Let's say if there is an in-between irrigation, then add that as well as irrigation. And October 14th is when it gets harvested. After that, field is left fallow. The consecutive year, for May 10th, you will have a phosphorus fertilizer, that is P2O5. That is applied at 45 kg per hectare. And May 24th, you plant it without any tilling. Soybean is planted without any tilling. Usually the corn stalks are left on the field. You are only harvesting the biomass. You are not killing the plant. So plant is still, so that gets added into the soil, organic matter. Then May 24th plant with no till. In between nothing happens. It was a mostly rain-fed. October 7th harvesting, and after harvest November 1st you do a tillage. So you want to remove the soybean plants, and that's what the tillage with a chisel. Now let's see how we can feed in this information to the swag model. Open the swag model. Okay, go to edit swag input, go to subbasins data, go to edit swag input, go to subbasins data. Now you have a list of tables. Where you can modify any of the input tables. That is soil, weather, subbasin, HRU, routing, groundwater. So any of the parameters can be modified. This management comes in management.md. Click on management. Go to subbasin 1. Any subbasin. Fine. Go to land use on. They need to follow, right? Okay. Select a subbasin. select the land use corn, select any soil. Your management practices are not changing with soil, it's only with the land use, and select any slope class. Select any subbasin which has corn and land use. Select any soil, select any slope. It won't make a difference. Just make sure that your land use is corn. Then click on OK. Thank you. Okay. Now a new window pops up where you have some general parameters which indicate different factors. You have curve number 2 here for this particular HRE. You have your P, then you have all different parameters. Initial land cover, when your simulation is starting, you can select whether there was initial land cover or not. We say no crop growing, that is on the first day of, we have data from January 1990, right? 1 January 1990, whether there was any land cover. In this agriculture, you can say it has no crop growing. If you say some crop is growing, some rabi crop might be growing. Yes. So you can give what is the initial LAI, biomass in LAI, and what was the heat units which is there. So usually consider some warm-up period. During that warm-up period, it doesn't make much of a difference. If you want to add that, you can always add it. If you are developing a HRU based model, in that sense, this becomes important. Okay? All are here? Yes. Then you have, if it's urban management, urban land use, you have the urban land cover and urban simulation method. Irrigation management, someone asked about reservoir. Irrigation source, you need to give a reference. Here it will ask for reach, reservoir, shallow aquifer, deep aquifer. Shallow and deep will take from the same subbasin. Reach, if it is coming from some other area, then you can select which channel or which reach it is coming, from which reservoir. We have reservoir normally, from which reservoir it is coming, it is there, and if there is some outside source, outside the catchment, some source, you can add it here. So you have to give subbasin ID, minimum flow, and then what is the diversion, what is the flow rate, all those things you can give it. So then timelines, if you want to adjust timelines, you can do that. Okay, you have all the timelines that are in place. Go to operations. Now here is where the operations come into picture. Here, agricultural operations. Now by default, any agriculture or any land use that you take, or forest or agriculture, these default operation gets filled up. If you see here, year 1, first operation is plant and growing. This is the default operation. Corn, heat units is 0.15. Then auto fertilization, it will automatically give, it is giving a fertilization 0.09, and harvest and kill operation when your heat units reaches 1.5. Okay. Now this is a default which will be there. So when you use the AGRL or AGRR, some kind of similar default application will be there. Okay. Now you need to keep it for your particular crop. So even if you don't give your model result, it will not show you error that you have not given the data. Even though your land use map you would have put soybean, you have put paddy, it would take it like this. Now it is problematic in the case of a Indian cat. Our growing system is very different from a US growing system. US growing system is a summer crop. Starts in April, you have seen, ends in October. We don't have crop during that time unless it's very irrigated and it's a very small area. Our crops are in the Kharif and the Rabi season. And even if you are putting a paddy, it may be growing at a completely different time as what it actually will grow. So you need to do that. Put edit values. You can delete all the operations. One by one, you can delete all the operations. Done? Okay. Now click on add operation. Now a series of operations are available to you. Plant, begin of growing season, irrigation, fertilizer application, pesticide application, harvest and kill. When you say harvest and kill, it will harvest the yield from biomass and kill the plant. When it is tillage, it will just till. 7 is harvest only, it will just harvest the yield, the dry yield, and the plant remains in the field as it is. Kill or end of growing season, it will kill the plant without any harvest. Then you have grazing, auto irrigation, right? Then you have auto fertilization. Street sweeping is basically your urban land use. Release or impound is also urban. Continuous fertilization. For example, you have a drip irrigation system in your field, then the continuous fertilization or continuous pesticide is to figure out. And then skip to beginning of year. Go to fertilizer. First is fertilizer, right? Yeah. What is the first? Nitrogen application. First in India. Okay. Now once you come here, it will ask, do you want to schedule by date or do you want to schedule by EQ? We have the date, so we will go with schedule by date. So it will ask changing to date, you will set the management practices to Jan 1st. Yes, they continue, yes. Now our first one was April 22nd. Put April 22nd. Now it will add for fertilizer ID. So you have n number of fertilizers. Now what do these numbers mean? You can go back and check in your database. It's basically the ratios of NP and K. Most of the numbers are ratios of NP and K. But what exactly do they mean? Go back, check in your SWAT 2012 database. There is something called as fertilizer. Okay? So you can get that. Ours is what? You have your anhydrous ammonia, right? Anhydrous ammonia. Select it. Anhydrous ammonia from the list. Select that. Yeah. kg we have given 67 or 212. 212. Anhydrous ammonia is 212 kg per hectare. So you can just apply 212 kgs and click on OK. Right? Now your second operation is also application of the fertilizer T04 potassium. Operation, fertilizer application. Now again go to month April 22nd. Now P205 is phosphate. You can use elemental phosphorus there. Okay, there is one thing called elemental phosphorus. You can go ahead and choose it. Okay, choose that. Then application is 67 per kg per hectare. Click OK. Now on the same day we are also applying some pesticide. Click on add operation. Number 4 is your pesticide application. Click on pesticide application. Click OK. Select the date. April 22. What is the pesticide? Nitrogen. It is 2.2 kg per hectare. From the list, you see there are number of pesticides. So depending upon what it is, and let's say something is not there. So see what is the data that is required. And you can fill it in your fertilizer and pesticide database on your SWAT 2012. Okay? Put nitrogen 2.2 kg per hectare and then you say okay. What is the next operation? Tillage, that is on May 6. Tillage is the 6th operation. Everyone is here? Are we? Can we move forward? All the three operations happened. We are doing okay. Okay, everyone done? Okay, the next operation is delete. Go ahead operation 6 is delete. That is in May 6th. And you had a offset display. Search for it. Offset display of 100 mm. Just put it in. Offset display will be there. So your this thing, if you just over your mouse, it will tell you that it is a SCS curve number. Now when there is a delete operation, it changes your curve number. If you want to give it, you can give it. If you don't have any information, you can leave it at 0. Okay? It also has that option. You can say okay. Next operation is planting. That is happening on the first operation, plant beginning of grow season. Click on that, click OK. It says May 6th. that as soon as you put the corn, it gives you what are the heat units to maturity. Required 108 units, 8 units to maturity. Sometimes it varies from variety to variety. Right? All rice does not go in 150 days. Some goes in 100, 110 days as well. So depending upon that variety, you can harvest gives 8 units to maturity. Then, in case of paddy, it's always transplanted. Yes, how many of you know that? Very rarely it is seeded. From the nursery it is picked and put it in the transplanted. So that means it will already have a layer. Okay, it will already have a layer. So you can give an initial layer value. Otherwise, if it is seeded, the layer will be 0. Similarly, your current number, biomass, initial biomass, harvest in the target harvest index, and target biomass. All of them can be filled up. Here we will just leave it. You can click on OK. What is the next operation? Harvest on October 14th. Click add operation. It will be only harvest. Harvest only. Click OK. October 14th. Okay. There is something called as harvest efficiency. This is harvest index override. What is this? Biomass or grain harvest code. So if it is some grain, you put it as 1, otherwise you can leave it as 0. Then this harvest efficiency and harvest, there are some default values for each crop. But if you know what is the harvest efficiency, is basically how much of a biomass becomes yield. See, any crop model does not tell what is the corn yield. It's always a percentage of total biomass. You always simulate the biomass. From that biomass, after a certain point, some part is what we consider as yield, and that is what is your harvest index. Again, it depends upon variety to variety. Some new varieties are coming which are giving higher yield. So in that case, it will go up. That means more biomass is going into yield. Okay, so those values can be given. Just okay. Okay, so this finishes the first year. This finishes the first year of operation. Now, the next one is your second operation. Click on add here. First year is corn, followed by soybean. Right? So, to add year 2, it says plant begin or growing season. You can change to soybean crop. Put month is different. May 24th is when it is started. So initially, when you click add on here, it will always take the first operation. You may change the operation, but fine. We are just continuing. It's a new date. Close it. May 24th. So I mean 8 units to maturity are given. Again, all LA initial, everything is this thing. Click OK. Now add operation. We had a first operation of fertilizer application or tillage. Fertilizer application. See, what is that? Phosphorus fertilizer of T04. Okay, May 10. It gone in year 1. Cancel it. This one gone in year 1. You see, here it is showing year of rotation. You put the cursor here. Yeah. Now add operation. It has come in year rotation 2. Make sure that year of rotation comes as 2 when you add an operation. Otherwise, it will go to your first year. This arrow mark, you put it at 2. The arrow mark here, you put it at 2 so that it comes in year of rotation 2. Fertilizer application, click OK. Put elemental phosphorus, 45 kg. Click OK. May 10. Click OK. So everyone has added plant growing and fertilizer application. For the second year, make sure that you are adding for the second year. Okay. Now go to the next step. Harvest is on October 7th and November 1st is today. October 7th is harvest. Go to harvest. Put down. Harvest October 7th. Click OK. Every time you do. Add operation. Tillage. I think it's a diesel side. November 1st. November 1st is diesel. 15 feet distance. This is plant with no till now. Add operation. Edit operation. Plant with no till. No till farming. So it will directly till. There won't be any delay. After harvesting, you will just place the soybean seed. No till farming. Zero till farming. So it is the same. Unless we give the delay, it will not do the delay. It will directly sow. Done. Done. Everyone is here. Can we move forward? Yes. What happened? You are not filling. Huh? Add it. Okay. Now. Done? Okay. Now you have given this management operations for a single HR. You have 2000 HR. How many HR is 600? 600 HR. After that, there is also you have to give now. Select on two. Now I have operation. First year only. Not even adding. Yeah. Everything I have got added in first year. Yes. No. Only 2 are added in second year. So 6 to 9 is very much harvesting, and 14 again we are harvesting. Okay. Now, as I was saying, this is only for one HR. It needs to be done for all the one HRs. Okay. Now, for today's session, we are assuming that entire watershed is following a same management practices. But let's say in the Indian context, it's not essential that it will follow the same. If there is a basin which is on multiple states, there is always a variation in some management operations. Okay? Sometimes it's same, sometimes it's different. It may be different from one district to another district. In that case, you need to identify all the subbasins which are having same. But here I am assuming that all watershed is same. So you will click on extend management operations, extend edits to selected HRUs. What are the HRUs? I select all subbasins. I select corn as a land use. I select all soils and all storm. So wherever the corn is growing, it will save these particular management operations. Another thing is, you can also save the schedule. Let's say you want to use it for some other time in a different model. You can also do that. You can save the schedule. Click on save. Just say corn management operations. Because entering the data takes time, so you can always save the schedule. And let's say there is some minor modification in a different subbasin. You can save it and load that. Corn schedule. Just say OK. Operation schedule, load. You save it. Once you select extend edits to selected HRUs, all subbasin, corn as land use, all soils, all slopes, you go ahead and save edits. It will save as edit save. Click on OK. you do it on your own. Go to the soybean class, go to land use, soybean, land use, slope, click OK. Go to operations. When you see here, soybean is still the same. Okay. Now, whatever was in year 2 becomes year 1 for soybean, and year 1 becomes year 2. It will start with soybean and end with corn. So add that management operation on the top. Do it quickly. Same thing what we have done, only the year changes. Okay? You want me to put up the management practices here? You want me to do that? Yes? Okay. Fill it up. Delete all operations and fill it up. Do it schedule by date. May 6th. May 24th.
सोयाबीन का है सेम क्या है लिखा हुआ है छोटा सा लिया तो क्या किया तो अभी पता है छोटा है शायद लेकिन इस ये फर्टिलाइजर हमें डालना है
You are it for soybean as well? But again, we need to modify it, right? We need to change the year.
May 24. May 10 is fertilizer. May 24 is their planting. 7th October 7th is your harvesting. November 1st is tillage.
Okay, everyone is done. Particular line parcel goes for vector cell. Now in the same year, the classified form separate. The other parcel are showing vector cell form. Particular we have separate. Okay, was completed. 1, 2, 3. We need more people to complete. So if you have completed, you do the same thing. Extend management operations, extend edits to selected HRUs, all subbasins, select soybean, all soils and all slopes, and save the edits. Done? Can we move forward? How many are yet to do? Only one, two, three. Okay, are you done? Have you saved it? Have you extended the management operations to all land users corresponding to soybean? Yes? No? Yes? Good to done?
suggest extended management operations, extended it to selected HRs, all subbasins, soybean, all save edits.
Okay. So once you have extended edits to selected HRUs, now what you have done is, for all the HRUs which were going on, you have given the management operations. For all the HRUs that soybean was going, you have given the operations. Now these operations are written only in the database now. It has to be transferred to your text in out or the input files. And for that, go this. For that, you go to edit SWAT input, you go to rewrite SWAT input files. Click on rewrite SWAT input files. Here it will ask which file to be rewritten. We have done modifications only in MDT files. You select that and you put write files. You click on write files. Whichever file you have modified, you need to do that. Here we have just rewritten or we have just modified the management files. You can just put it as .mdt and click write files. Done. Everyone is here? Okay, close it. Now your model can be run. Okay, most of the information is there. Go to SWAT simulation. And first one is run SWAT. Click on that. Now it has a starting date and it has an ending date. This is taken directly from the climate data that you have given. Climate data was starting from 1/1/1990 and the last data point was 31st July 2014. Right? If you want to run it for so long, you can, but if you want to run it for some specific period, you can change it. Let's say I want to run it only till 2010, make it 2010, 31st December 2010. Okay? 31st December 2010. Now there are different options here before you set up the SWAT model. The first setting is printout setting. In general, your SWAT model is going to run at a daily timestamp. All computations happens on a daily timestamp. But you can print it at a daily timestamp, monthly or yearly. Let's go with daily. Okay? Now there is something called NY skip. This is basically a warm-up period. So it will skip printing number of years that you want to use here. Let's say 3 years. So when we say 3 years, that means it will not print results correspond to 1990, 91, 92. Model simulation will start from 1st January 1990, but printing of results will only begin from 1993 onwards. 1990, 1991 and 1992 will not be printed. Then, in addition to other outputs, you can have different outputs. You want to print soil nutrient, it can be printed. Print water quality output, print management output, you can print it separately. Log flow, hourly output, if you have some hourly data, route headwaters, snow, WTR output, you have different combinations which you want to print. Then you have soil storage, print soil storage. If you are interested in soil moisture, you need to go ahead and print soil storage. The soil storage will be printed for each specific layer. Close it, you don't want it, it takes too much time. Now coming to your output file variables, there is an option of all, minimum and user choice. If you print all, everything gets printed. It creates a large file, few GBs file. Right? So let's say I am not interested in HRE output, you can go with user choice. So user choice, your output file gets printed in 3 ways. One is the reach file, that is for each channel. Subbasin file, subbasin average values, and for each HRE. So if you are interested in a specific HRE output, you have to have an HRE output. Okay? What all output you want to have. Otherwise, if you are interested only in reach, only in subbasin, you can print this. Select all for each file. Select all for precipitation file and HRV file will let it be. Let's not print for individual HRVs. It takes lot of data. Click OK. So you have taken a user choice. Now your executable version, it depends upon what is your system. It is a 32-bit system or 64-bit system. Most systems nowadays are 64-bit. Now there is the option of debug and release version. Release is basically to just evaluate if some error comes, you will not be able to see. It just says if pattern was not successful. Now when that happens, you can go to the debug version, run it and check what is the error, where the error is being caused. Right now let's go with release. Click on setup swat run. Now once you do this, once you click on setup swat run, you don't need GIS anymore. You don't need RPS interface anymore. You can run it from your executable in your textinote automatically, right? And that is what you can also use swat user.exe in textinote folder. Custom swat, you can always use that. Let's say you have modified a swat code. You don't want to take the inbuilt swat code. You can create an executable, and that executable can be used to run custom swat user.exe. Click OK and click on run swat. Okay, a window gets open and it will start running. That is for climate data. If you are having some, most of your weather related data doesn't have any this thing. The field is too small to just click on this. Just basic of swat cup and then we have to more. Okay. And after this gets done, the next batch will start. Yeah. That's it.
At HRU level also we will have all the processes. So in SWAT, suppose here you have run at a daily time step or a monthly time step. Daily time step. So all the computation will happen in a particular HRU. Let us say there are 700 HRUs. So for every HRU, for every day, water balance will be computed. So for every HRU you will have sediment, evapotranspiration, stream flow available, and that will be summed, or that will be like total of that will come at your subbasin outlet, and that total will come at your whole watershed outlet. So HRU is the fundamental computation unit. Once you are done writing the files, all are done writing the files, you can click OK, and then you can run SWAT check. It will give you an idea of how overall processes have occurred in your watershed. It is just to have a summary of what has happened. So you can click on examine model output. You can click on examine model output after clicking on SWAT run check. Here it will give you a brief report of what was your simulation length, what was the warm-up period, and how many HRUs were created. And then in each section you have the response. For example, go to hydrology. Here you can see what was your average precipitation and then average curve number. This is coming for whole watershed. Run, that was the first simulation without changing anything about our parameters. We will save it. You can give the name of your choice. We will write sim1. This is the first simulation, and we will save it. So is it saved? Okay, now you can close this. You can save your project setup, and now you can minimize it. So in your project directory, in the scenarios, one folder is created in the scenarios section, and that folder sim1 will contain all your information about the first simulation. From here we want to extract our output. That is our goal. So here you can see there is a folder named tables out. Click on that, and it is showing one access database file, SWAT output. Click on that. So here you can see, since we imported only 3 files, output.reach, output.sub and output.hru, it is giving us only these 3. If you select all, it would have taken more time. So for simplicity we have imported these 3. Click on RCH. Just double click on that. Now you can see, let's minimize this one, the tables. So you can see for every subbasin, for every year, and it is starting from 93 because we have given the warm-up period. So, and for every month, what is the area, what was the flow at the outlet for subbasin 1, what was the flow outside, in and out are given. So this flow out is nothing but our simulated discharge. This is what we will extract and calibrate our model with. In case we are calibrating our model output with discharge, this flow out is the column we are interested in. But this flow out is available for all the subbasins. So what is the subbasin number that we will choose? It will depend on where is your outlet. Suppose your outlet lies on watershed, on subbasin multi. So outlet means I am talking about the main outlet. So your main outlet you can check in the ArcMap document. Just we will display here. Here you have one layer watershed. In the ArcMap you have the layer watershed. You just label it and get to know where is your outlet. Subbasin number, which is the subbasin number containing the outlet, and for that subbasin you can extract the discharge. In case someone is going for multi-site calibration, they can take the multiple outlets. So we are trying to label our subbasins.
Here you just click on, right click on watershed, properties. Just click on here, label feature in this layer, and here you just keep subbasin. Okay, then click apply. So you will see subbasin numbers.
So you can uncheck all the layers and just keep your main outlet and the subbasins to identify where is your outlet. So outlet is in subbasin 32 for
Might
this
be varying
case.
from person to person based on threshold or what you give that time. So just check main outlet and which main outlet is following this service. Here it is following on 32.
And in case of multi-site it may happen at subbasin 15 and subbasin 32 you have the outlet, so you will extract for those subbasins. So all of you have identified what is the subbasin where your discharge is. Okay, so you go back to your Access database and here you can put a filter on subbasin number. So we will select 32 because our outlet is in subbasin 32. And we will extract this flow out. There are many ways to do it. You can read this file, you can read this in Excel, you can copy paste this column in Excel, or you can give it to any programming language of your choice. It will give you the flow out, and since it is daily simulation, so every day you have the values. So 6574. So it will continue from, in the month column it will continue from 1 to 365, again it will come. So you will have the time series of discharge and you also have the observed discharge. You will compare. You can compare how your model has performed. Apart from that, you can see the two columns next to that, sediment out. Just scroll it to the right. So you have sediment out. So this will give you your sediment yield for multivariable calibration in case you want to see how well your sediment has been simulated. Again, you must know where is your measured sediment. If it is there on the main outlet, then you will give that subbasin 32, or else you will change according to where your outlet is. Then like this we can analyze for multiple outputs. Go to the left and show those tables. The left table. So like this, go to subbasin and you can see for every subbasin you have evapotranspiration, potential evapotranspiration, soil moisture, all those things. And what is that meaning of each term you can know here in the table sub depth. It will tell you the units also, in what units that quantity
स्कोर काय बोलते
and then go
आपल्या
to
ऐकू
HRU. So here at HRU level also you can get the outputs. Scroll it to the right. In the minimum user choice. Okay. So that is why it has not come, but if you would have printed for all, then it would have appeared here. So like this you can read the outputs and you can compare it with the observed. You can understand, this is basically the uncalibrated SWOT output that was being discussed in the lectures.
What I would suggest is prepare an Excel. Identify the surface and outlet. Did you identify the surface and outlet? Take out at that particular point the stream flow, sediment, and nitrates, subtotal nitrates. The uncalibrated one. Let's try to see it after we calibrate how do those numbers change. Can we do that? Let's do that. Prepare an Excel file or something.
So you can extract for your main outlet subbasin these three variables.
Let's put the date. So
Just go to the rightmost column. The rightmost, scroll it to the right. Yeah. So you have a date column also. Copy the date and the three variables.
or in the Excel if you just click it will automatically come. This only days. Under 365 days.
Sir, this figure for transportation is in elements. So if you go from higher to the higher level is 6.77 mm. Is it possible in a particular day it will be possible? Because in this picture say maximum range is 2 to 3 mm.
Depends on where you are. See, if it is a 1000 mm rainfall, we said 60% of that. So 600 divided by 300 is 2 to 3 mm. Now, if it's more humid area, then it changes, right?
But for nitrates and growth, you have to take out value or out minus in value.
So take the out value. What is the out coming up? Or you take total nitrogen, either way this fine. The out value. Out minus in will primarily give from that particular subbasin. What is being generated from that particular subbasin? I want take the watershed outlet. What is coming out of the watershed? Save the Excel file in the folder. Save the Excel file in the folder that you have project. Okay. So what we'll do is we'll stop here. He is getting ready. He is coming. Let's do the calibration tomorrow. Let's do the calibration tomorrow. I think we do for 2 years. 2 years. 3 years.